So the gradient of a straight line, this is also known as the slope, but we rarely use this word. So the gradient of a straight line is simply the steepness of a line. So when you have a line like this, which is parallel, or maybe, let me just put it like this, parallel to my table here, then the gradient is 0. And then as you are moving it up, it's becoming steeper and steeper. As you can see, that means the gradient is becoming bigger and bigger until you have something vertical like this, which is said to be an infinite gradient. So to find that gradient or that slopeness or that steepness of a line, this is the formula we use. You can either say y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2. So whether you choose to use this or this, your answer will still be the same. Just make sure that if you start with the 2's, you end with, if you start with the 2's on top, if you start with y2 on top, you should have an x2 on the denominator. You have a y1 on the numerator this side, you do the same. The same applies to this. So I rarely use this, but you can use it if you want. This is what I mostly use. So let's try to make use of it to look at these few examples. So to find the gradient of a line, A connecting the points A and B, you can simply say M is equal to y2 minus y1 over x2 minus x1. So let's name the points. So I can call these points our 1's, then these ones will be our 2's. If you want, you can name these your 2's and these ones will automatically be your 1's. So to find the gradient here, you can say my y2 is 4. As you can see, this is a 4. Minus my y1 is a 6. Then everything over, our x2 is 2. Then our x1 is 4. Like this. So my gradient will be 4 minus 6. This will be negative 2. And then 2 minus 4. This will be negative 2 as well. So now when you divide these two numbers, you have a 1, which is positive. So that means our gradient for the points A and B is 1. This is how steep the line is. And by the way, we don't have units for the gradient because this is like, let me just say it's the ratio between the y coordinates and the x coordinates. And then on part B, we have something which is even easier. Let's find the gradient between C and D. So the gradient is equal to, by the way, we use the symbol M to represent the gradient. So the gradient between C and D, sometimes denoted as gradient CD, this is small letter m by the way, is given by, let's try to use this one, y1 minus y2 over x1 minus x2. And then let's name these points. We can say these are x, y, and then let's name these ones 1's, and then these ones will be our 2's. By the way, this is CD. So our y1 is 0. This one here, and then our y2 is 3, and then over our x1 is 0 again, minus our x2, which is negative 3. So this minus this is negative 3, and then negative and negative will be positive. So 0 plus 3, we still have a 3. Then 3 into negative 3, we have a negative 1. So we shall talk about this relationship where you have something that is giving you a 1 when you multiply this by that. So this is the gradient of CD, like this. And then on part C, we have 2 points, E and F. So to find the gradient between E and F, you can simply say M is equal to y2 minus y1 over x2 minus x1. And then let's name the points x comma y, and then let's call these ones our 1s, and then these ones will be our 2s. So M is equal to, our y2 is 3 minus our y1, which is a 0, and then x2, our x2 is 0 minus our x1, which is a 2. Then you can subtract this minus this, you have a 3, 0 minus 2, you have minus 2. So this is like negative 3 over 2, and this is your gradient for part C. This is a very simple concept.